And the decision variables.
Need an alpha j, which is 1 if it's used and 0 otherwise.
If delay is used. Okay. And
an xj, which is the amount of bobbins that it produces.
what did you say you wanted to call it?
Xj.
XJ? Okay.
Why?
Matter. I don't have any preference. So XJ is, what should we call it? Probably best number of bobbins produced on lathe J in thousands per hour. The question is related to the first year assignment with Coppersing, because the wildfire forest. Because Coppersing provides the woods. So these are the decision variables. What is the objective?
You want to minimize the sum of all the j's and j's of alpha j times by the fixed cost, which is a plus.
You want to minimize the sum of all j in j, alpha j times the fixed cost. What's the fixed cost? AJ.
Plus the unit cost, which is uj, times by the amount. So
Plus uj times xj, like this. What's it missing? Sorry? I didn't quite get that. UJ from the decision. No, XJ. UJ are not decision variables. UJ are up here as the cost. Yeah. So no. So UJ is not a decision variable. AJ is the cost here. Maybe I should have. I was lazy to repeat this. But in the answer, when you're doing the exam, actually you don't have to repeat the data. You can, if it helps you. If it helps you formulate the answer, you can write down neatly what is given, AJ, EJ, Q, and NJ, and J. You could do, but it's not necessary to put it there for the correctness of the answer. Just start with the decision variable's objective constraints, that's enough. So EJ is part of the parameter. This shouldn't be greater than or equal to anything, but what's missing? Where it's missing is brackets, because if you don't put brackets, then the sum only applies to the first thing. Okay. Look, it's a book. It's wrong without them. Constraints.
Sum of all your xj's is going to be greater than or equal to the demand, which is Q.
Sum of all these xj's, should be at least Q. I agree.
Xj is going to be less than or equal to Mj. Only one the same thing. So like Q, Xj. Xj has to be somewhere between the demand Q and the maximum. If it's not the sum of Xj, it's just Xj's got to be less than or equal to the sum of Xj's.
Xj has to be less than or equal to Mj.
Just each Xj has a maximum. Not all the maximums need to be added.
Objection withdrawn. Yeah. Okay, tentatively, I could accept this.
Xj is going to be greater than or equal to 0. So you can't make any other.
Okay. Nothing.
Then the alpha j has got to be the belong to 1, isn't it?
Anything else? Yes. Because like this. Okay, I'll wait for everyone to catch up. I know exactly what the value of each alpha is going to be in the optimal solution like this. It's going to be a 0 for all of them. Because there's nothing stopping you putting your xj to something positive without putting the alpha shape to 1.
Some of
The sum of alpha j is the number of blades that are switched on. We don't know anything about that. There you've got mj. Multiply that by alpha j. Yes, that's what I would do. Thank you. That's the usual trick how you can make things 0 if some kind of 0, 1 indicator is 0. Make it less than or equal to some constant times alpha j. And if you know what the constant is, like in this case, you know that the maximum can't be more than this number. But in situations where you don't have an upper limit of the production, so if your blades were somehow super blades and could do an unlimited amount, then you'd have to come up with a large number that doesn't. For example, you could put the demand there, because you certainly won't be making more than some other large number there, whose job will be to ensure that this is 0 if that is there. Is there anything else there that we need? I don't think so. So 10 marks done. I think. That's a good start. We'll do a couple of accounting questions and okay, good. Yes. So you have to know that the tableau, what it looks like. So when you have the basis, and this is the D, this is Z, this is the val. So the most important thing is this, the inverse of the MB matrix. And the MB matrix is a submatrix. We take the constraint coefficients and the identity and look at the columns that correspond to the basic variables. So in our case, the coefficients in the constraints are 2 and 1 for x1, 1 and 3 for x2, and then these are the slack columns. You want to take the first and the second column of this. So in this particular case, you don't get anything else than the matrix A back, which is So we want 1, 3. Now, you have to do the inverse. So either you can do the inverse out of the bucket for a 2 by 2 matrix, you should be able to do. Right? Or use MATLAB or something. So how does one do matrix inverses? By hand? Yeah, it's 1 over the determinant. The determinant is 5. So it's 1 over 5. And this is something like 3, something like that. 3 minus 1 minus 1, 2. This is MB inverse A, but we don't have to do it because B inverse is A inverse, so this is the other. This is MB inverse B. So 3 minus 1 minus 1, 2. And B is the right hand side, 5 and 10. It's like 1 and 2. It's 3 minus 2 is 1. Okay. Yes. Now, this is CB MB inverse, is it? Yes. This is CB MB inverse A minus C. This is CB and B. We don't have to do it in matrices. You have to remember that you just look at the basic variables in the tableau, look at their objective function coefficients and times each row by the corresponding objective coefficient and add them all together. And in this part, you have to subtract the original objective coefficients. You don't want to be too complicated. Okay, so in our case, we know this is going to be 0 because they're the basic variables, so we don't need calculation there. CB, that's the cost coefficient, or the objective coefficients of the basic variables, so 3 and 2, straight from the objective here. Basis is x1 and x2. And CB that's this matrix. So you get 9 minus 2 is 7, I think. So it should be 7. Minus 3 plus 4 is 1. So it should be 1. Yes. And CB and B inverse B is just this times by B, which is 5 and 10. It's disappeared. No. Yes. Is that right? Another way to, so there are two different ways. Two different ways to get this. One way is you already know this. And D is the right hand side. And the other way is this is the new column there. So you know that x1 is going to be 1 and x2 is going to be 3. You just put it back into the objective. So 3 times 1 is 2 times 3. It works. Okay, it's a lot of matrix calculations without much commentary written down. Any questions? No? Well, let me just very quickly put them all together, and the answer should be the final tableau looks like this. The basis is x1, x2, z. The values we said were 1, 3, and 9. And we have x1 is in the basis, x2 is in the basis, s1, s2. So what was this inverse matrix was 3 over 5 minus 1 over 5. And this bit here is somewhere here. And that's the answer.